Hey guys, welcome back to the channel. I have another interesting video here. This one is now on a 2009 Mini Cooper S. This is an R56 N14 engine. You'll see it on the screen recording. The last digits on the VIN number are A0198. Customer concern is the code 2D7F, which also in generic fault codes goes to P3100. I have that information in here. This is for us and you. Um, I can zoom in here a little bit more. All right, so this is again original information. It says the code 2D7F converts into code P3100. Sorry, yeah, P3100, which is cylinder one high pressure fuel injector, low side circuit open. This is diagnostics internally in the computer. As you can see here, I have been doing a very extensive homework. This is sometimes a little hard, especially when it's on injector. These are GDI injectors, and so it's very different. As you can see here at the bottom, I have mapped out, do my reverse engineering on all the faults, sorry, all the lines in that goes into injectors and coils, and I take the time to put the connectors. You can see here the connectors on the computer itself, so I can easily see where everything is, because otherwise it's pretty much impossible. A few things that I want also to show is like in here, we got the wire diagram for the injectors coming straight from air, as you will see here. But injectors on Mini Cooper, BMW, are Y6101, 6102, 6103, 6104, and so on, depends on how many injectors the vehicle has. But if we see, and this is why you sometimes have to check even your original information. As you can see, this is coming from BMW Mini Cooper website, original with the VIN number of the vehicle. We have here A0198. And it's telling me the injector one, I can see here, injector one, right, is on connector X60232, which is correct, but it's telling me that our pins 4 and 9, and that is wrong. It is pin 4, but it's pin 29, and that is very difficult to see something like that, an error on even on original information. Reason I can say that that is incorrect is because, as you guys see, I have already mapped the computer out, and I can see every single line, and it's 4 and 29. So um, we can also go over to the DME pinouts, which I have here. And if we go over to X620232, right, which is the small connector 32 pin. Sorry, I'm going a little fast for that, but okay, so if we go pin 4, supply power. And this is very good hint right here because we don't need to guess. Because if you go over to Identifix and you go into the wire diagrams, color wire diagrams, which I have here, I can show you in a second too, it tells you nothing. So yeah, injectors, all the components are there, but nothing on the connector. What is the power? What is the ground? No. So this is the way you can find out. So, and then if we go over to P9, signal for ignition coil cylinder 2. So that's nothing to do. So pin 29, on the other hand, it tells signal fuel injector cylinder number 1. So that's how I find out that that was an error even on the original. And if we go over to the color diagrams, I want to share all the information that I always gather is on page, I think it's page 3. Yeah, this is the coils. All right, so we got the fuel injectors in here. Again, this is from Identifix. As you can see here, injector 1. At least the pinouts are correct. So if we follow this, we'll go to pin 4 right here. I don't know why when I'm in the Adobe, that cursor changes color. I put them in red color, trying to show you guys better, but so it's pin 4, and if we follow the other wire, it goes to pin 29. So that is as much as I think I can show you here. Um, So I started doing some tests on the computer and I couldn't find anything with a multimeter oscilloscope. In this case, again, it's very hard for me to reproduce the entire computer. This is a immobilizer. It has, a very intricate immobilizer on DMEs and BMW setup. So without the entire system, you cannot really run the entire computer. But that doesn't stop me from checking it, right? From testing it and checking it correct. Multimeter, I have continuity. I'm going to show you 1 second the board that I have here. Um, Make sure that you guys can see that. All right, so I'm going to just briefly show you here. If I use, again, a multimeter that can burn you, and that's why, using continuity is good to a point. If I put the tester here, this is for injector number 1, and I touch the driver here. Can you guys hear that? It's beeping beep. If I go over to the next one and I remove the diodes in here because I'm doing a test, right? Same thing. So you'll say, all right, so that's good. Diodes are good. You can use diode mode in any multimeter. Let me move this away. So if you want to check a diode, all you got to do, can you guys see that? I need to move this way a little bit. Yeah. You go over to diode mode. It's very hard to use too many tools in my bench. But so you just click the line on the flux and you can use the yellow. That will beep too. But then you can check a diode. So if I check this diode, it's open line that way, and then it's going to be around 1.4 this way, and then it should be like zero point 0.4 volts. So 0.4 volts this way, and then open line on the other way. So those diodes are fine. And I check all the diodes, and all the diodes are good. He opened this computer, Sean Bullock. This is your computer. You open it up, and there was some broken components caused by whoever opened the computer, which not a problem. I have it here, but yes, I have to correct that in order to test completely correct the computer. All right, so going back into the test that I'm doing. So with this multimeter, I would have like, okay, nothing wrong. The computer is perfect. And okay, well, what's the problem, right? Because broken components and everything is not well, the computer is in here. So they did that when they opened the computer. Please, guys, send me the computer. I open it up. I can test it. Let me just make sure you guys can see me. Okay. I would rather have the computer or open this. Sorry, let me put this back here. I would rather be me the one opening the computer because there is some components that are very hard to find and very expensive, and that can at the end make a computer uh, you know, not repairable. So be careful when you're doing that. All right, going back into the information, as you guys already see, I got all the powers and grounds and all the stuff. I always do the test on the computer, and I get the supply for the DME. This is, again, based on the B number. We can see here on this computer that we have um, connector X6304. I can pull the connectors in here. For those that didn't see that um, on the other videos, I have been working on DMEs and Mini Coopers and the ones that have 3 connectors are always going to be X604, X60231, and X60232. Uh, or it can be X60, 212, or 211. It depends if it's N16 or N14. That changes those numbers, but you will see that always the small one is on the right side. And then, okay, so powers and grounds are all in the connector X6004. We have the ones, at least for my tests, I just use 5 18, and as you can see, not N16 and N16. So I will be using pins 16. Grounds are always going to be 3 and 4. You can use 53. These grounds are all shared inside the computer, so you can use just the one ground for bench testing. Remember, what I'm doing is bench testing. I also made a list. Okay, we got the, sorry, going back to here, step by step. We got communications and pins 40 and 52, which is the PT CAN. Again, this is just a CAN bus. BMW Mini Cooper uses this PT for internal communication on the vehicle because the communication for the scanner will go through a gateway and that is separate. All right, so this is the internal communication on the car. It's a fast communication. So this is powers and grounds. This is all I need to use to power up this computer. And then depend on what the concerns are on the customer, I go and check for all the sensor grounds and everything, or fiber reference and etc. So I did the homework, as you can see here. This is for the injector, so I know which one is the positive and which one is the negative. I know that it's in connector X60232, and then injector number one, Y6 101. It is always going to be on BMWs the same. Um, Again, what I just described before, all powers, all grounds, and communication will be in connector X60004. Fiber reference are on the three connectors. You can go and you will see supply for pedal position sensor, supply for refrigerant pressure sensor, supply for camshaft, for camshaft, or etc. So all those are fiber reference, even though they're shared internally on the computer. Uh, Let me rephrase that. There, this computer has three fiber reference, as we see on other videos that we have on Mini Coopers. This voltage regulator is in charge of the fiber reference for the computer, the microprocessor, which is completely separate of the sensor's voltage, and then it produces also three different fiber rails. So if any of those sensors are shorted, and you will see if you go back to Matt Pretmore video, why is that they did that, so the car can somehow run and depends on what is shorted. But so this computer uses three fiber references, and that's how this works. Yes, got something on here. Let me make sure my computer, this is still recording. I gotta check this out. Yeah, it's still recording. Am I in there? Yes. All right, so these are all the fiber references that I will need to check, and and depends on what is the computer concern. Again, going back to Sean, his concern is full code 2D7F. 2D7F injector number one. I did again all the homework for that injector, and I know that. Let me make this a little bigger. As you can see, I put, I made, all these marks on, I use, what is this? Paint 3D? Yeah, Paint 3D, this one. Yeah, I use Paint 3D and I put, a nice high-end picture of the board, and those are all my work. I do the reverse engineering. If I find a data sheet for the component, I put a picture at least of the pinouts or so on the actual picture. As you see here, these are um, the IGBTs for the coils. I can also see, the control for the IGBTs and where it's located, et cetera, et cetera. So I do all that myself. A lot of people is like, why do you share that information? Well, I am not sharing you how to fix computers. I am showing you and my customers that I can repair your computers. So I do help a lot of people. There is us around the world and trying to learn this, but I am a business. When I become an instructor, then I will share all that information. Not yet, but maybe later, if I decide to do classes and I create a a paid subscription on my YouTube or on my own website, or if I want to do classes across the country, then that might be the case, but not yet. All right, so going on to this computer, you'll see that I have removed, if we go over to the screen capture, again here I can change 1 second and go over to the microscope up and I move it. So that's why we don't see anything. But so as you can see there, I have removed the diodes for injectors number one, and what is the other one in here? I think it's number one and number three. X number four, number one and number four. You see what that's what I put those mark in here, number one and number four. So I removed those diodes just to check the signals because I'm also using the curve tracer. And the curve tracer is coming up in a second, and you will see what I'm doing with the curve tracer um, on this screensaver. Um, I cannot use both, and I would rather. Oof, that was very loud on my ear. You know what? I'm going to stop the microscope and keep going with the screen capture as I have here. What you are seeing now on the screen is my curve tracer. This is the UCE-CT 220S. Look in line for that. It's a very good, capable tool. Um, I am in advanced mode, so you can go basic mode or you can go on advanced mode, and then you can, when you are in there, you can load data, load image, scan data, sorry, save data. When you are here and you want to load an image, you just click that and that selects here. As you can see, I have all these test points in here, so I can start on pin, on pin one, oh, sorry, on test one. And if we look in the image right here on the right, um, it it makes that X move into that first diode. And this is the result. That red line now on here on the left side of the screen is the result from the curve tracer. So I can go test point. The next test point is the other side of that diode. If I go move into injector number one, you see what I'm seeing right there? Is this point right here, it should be all the same across these four diodes because they're the same point, same thing on the other side. Because if we see the other side is the same, so that point is the same as this point, and then as this point, and at this point, right? Those the four diodes. So the first one should look like that. The second one, sorry, not there, should look the same as the one before or all the same, because if I go over to the third one and if I go over to the fourth one, they all look like this. That's a diode. But this one is not. Not this one. This one is not looking like that. I cannot see that with the multimeter as we just saw there. You know how it was a completely uh, continuity, like everything is good. It's not. And I'm going to show you that on the board. I'm going to do the same test with the curve tracer. So I'm now going to again move the camera so you guys can see what I'm doing in there, and you will be seeing the screen recording at the same time. So, and then I will show you what my findings are. So again, if I go over here, and this is the nice thing, if I start with the first test, right? So if I go over to the first test, which is here, see, perfect match. I go here. Oh, I have to move the test point. Perfect match. If I go over to the next one, it's now even completely. This is a full open. Before it was reading something, but now it's a full open. It shouldn't. And the reason I'm saying it shouldn't, because look, it's not about the diode. You see, because now the next X point, see, look at the image right here. Also, that tell you this in here is also the same. So if I go over to the next one, which is the next text point on the third diode. Even the diode is not there. It's the same. So this is not this diode, what we're looking at it here. So that signal is not because of this diode. It's because of the internals on the injector IC. And I'm going to show you that in a second. So if I move over to the last one, it's the same. You see, it's exactly the same. These signals, as we can see here on this image, let me zoom out a little bit and move this over. If I go over to this first diode here that we have, let me just make sure I'm connected and the point. Okay, right there. So that is kind of like a square or I don't know how you call that image, but you see this right here. It's like a block, but a rhomb. I don't know if I'm saying it correct. It's right here. So that's I took the time to follow that. And if I go over here, come on, right there, it's the same one. If I go over to the next one, which is that square right here, see, it's not doing anything. I'm really there. And I can show you that I'm good because right there, see, it's, come on, it's reading there, but not reading in here. If I go here, which is again a square and then a square, I can zoom in a little more in here as this stripping is not the fourth one and not the first two. So I can go over to the third one and wow, the signal is perfect. So that signal is good. The component is good. So then why is showing me an open circuit in here? But we put the multimeter before, right? Remember, guys, that we put the multimeter from here to here and it's beeping. That's why you don't use the multimeter. Because guess what? There is an open between here and the component. Not here, because if I touch here, we got the same open line. So the problem is not actually here. It's from here to here. Now let me take you over to the microscope. And that's what I had the microscope in here as well. And now let me move this to here. That's going to be a little shaky, but it's worth for you guys to see how important it is to have good tools and test the components correctly. Because look at this in here. You see that? The three legs on that component right here. You see that? How it moves? Moves. So this component is not touching the pads. Heat. This means that he has most likely a shorted injector that is drawing a lot, and this component will need to be replaced. So I'm definitely moving this component out. Let me go back to the screen recording so we can at least see that image in here. And let me put you guys so I can talk for the closing of this video. This is the importance of having good tools. Take your time to do the correct tests and repair something. This is not something you will learn in a week. This is years and years of experience and taking my time to really do reverse engineering in computers and then being able to help people around the world because this is not just in the United States. I got people sending me stuff from Finland, Virgin Islands, just name it, and I'm very happy. It gives me a lot of satisfaction to enjoy the knowledge and share some of the knowledge around too, because these type of tests you can also use in your vehicles. This is not just for the computer. You can add the injector, you can use a curve tracer and see the same result, and it will work. That's why you need to have sometimes tools like this if you want to do advanced diagnostics in a shop. And I try to share these as much as I could. I think this is a very good finding. It's a very good way to show that we know or I know what I'm really doing in here. I got a lot of computers to work. I'm going to tell you right now, I've got probably On the bench, I got 15 to work on, and I have 3 racks full of computers. So if you're sending something, just contact me. All right, guys, if you guys need to contact me, just go over to my website, www and Mike Salazar Diagnostics, and Mike spells as MAIC, or the email, which is the same, Mike spells again MAIC, and then MikeSalazarDiagnostics.com. All right, guys, I don't want to take more of your time. I hope this helps somebody, and also if you need help with your DMEs, I'm here. I can help you all the time. Mini Cooper DMEs, BMW DMEs, just send it to me. I will be able to help you with. I got most of the parts in stock. Please, again, try to not open the computers. I'd rather you send it straight to me and I open it up. If you decide to do it, I mean, it's your computer. But if something gets too broken, I'm sorry, but I might not be able to help you. All right, guys, thank you so much. I see you next time. Don't forget to subscribe. Bye bye. See you next time.